I'm Won Lee. Today, test for equal variances of two independent populations. Okay. Chapter 5, test hypothesis. We try to test for equal means of two independent populations. In that case, we had to consider two cases: equal variances of two populations or unequal variances of two populations. Okay, let's see what I'm talking about. Is like this. When testing hypothesis whether there is difference between means of two populations, okay, for that case, it can be explained by considering whether there is a difference between variances of two populations. Say two populations here, okay, then we try to test a difference between means h naught mu1 equal to mu2. But in this case, we considered a sigma 1 square equal to sigma 2 square, b sigma 1 square is not equal to sigma 2 square. For this case, we had to estimate pooled variance estimator. Remember? Yeah. The task of testing the hypothesis that variances of two populations are equal requires an understanding of F distribution. That's why we delayed. So it was postponed. Now we will test hypothesis regarding the variances of two populations. Okay, for chapter 5, section 9, I think. Anyway, 5-9. The hypotheses are as follows. Okay, we want to test H naught, this case. H0, sigma 1 square equal to sigma 2 square versus H1, sigma 1 square is not equal to sigma 2 square. See here. Remember this kind of a diagram, I think. This population Y1, second population Y2, normal distribution, mu1 sigma 1 square, mu2 sigma 2 square. We obtain samples from here and another set of sample from here, right? But now, okay, we try to test this one. Then it is just the same like this. Sigma 1 square over sigma 2 square is 1 versus not equal to 1, right? So the test statistic gonna be this, the same shape of parameter. So we try to test the sigma square, sigma 2 square, okay, is equal to 1. Then test statistic will be S1 square over S2 square. So H0 will be rejected when this value is very small. It is positive anyway, very small, close to 1, or large compared to what? 1. Does it make sense? Now, let's see F distribution. What was F distribution? It is a definition. Chi-square distribution, chi-square random variable divided by each degrees of freedom. Chi-square, another chi-square random variable, each degrees of freedom d2. The ratio of this one and this one follows F distribution, 2 degrees of freedom, numerator, denominator. Okay? Of course, chi-square 1 and chi-square 2 are independent. These two are independent. So now, let's see. Chi-square, we studied this one follows chi-square distribution. N1 minus 1 S square divided by sigma square. That follow, okay, chi-square distribution. Degrees of freedom, N minus 1. Okay? Let's see. So degrees of freedom, N1 minus 1. in this case, same shape, degrees of freedom, n2 minus 1. The ratio of these two chi-square random variables. Then the degrees of freedom cancel out. So S1 square over sigma 1 square divided by S2 square over sigma 2 square. This one simply like this. Then S1 square over S2 square times sigma 2 square over sigma 1 square, right? It is what? It follows F distribution, degrees of freedom, n1 minus 1, n2 minus 1. You catch it? As repeatedly mentioned in hypothesis testing proceeds under the assumption that the null hypothesis is true, correct? So under the null hypothesis, H0 is correct, in other words, this one, then what is that? This part equal to 1, right? So under the null hypothesis, F, tested statistic F equal to S1 square over S2 square follows F distribution with degrees of freedom n1 minus 1, n2 minus 1. Therefore, significance level alpha, the rejection region will be, okay, F distribution skewed like this. Okay, here alpha over 2. This part alpha over 2. Okay, because it is a two-tailed test. Then this value is, this is F distribution, degrees of freedom n1 minus 1 and 2 minus 1. So the value of F here, this one, this point, is what? n1 minus 1, n2 minus 1, alpha over 2. Okay, alpha over 2 here. Then what is this value? F degrees of freedom n1 minus 1, n2 minus 1, what? As chi-square distribution, we write down here alpha 1 minus alpha over 2. This area. Okay, so this tested statistic S1 square over S2 square, when it is greater than this value, this is a rejection region, these two parts. And this F value, okay, F is S1 square over S2 square. The value of F lies here, then we reject this, what do we call? Critical values, okay? F n1 minus 1, n2 minus 1, 1 minus alpha over 2, this value. Can you see this? Okay? F value, sorry, F distribution is one of the most, complicated distribution, but very, very important in statistical analysis method. You will see F value here and there, especially regression analysis, next chapter. Okay? I hope you understand this part easily. It is an interesting tip like this, as like this. Mu equal to mu2, mu1 equal to mu2 is equivalently mu1 minus mu2 equal to 0, like this. Okay, I will continue a little more next time for F distribution. All right, this is it today. Thank you. Bye.